The Prentice Institute has sponsored a number of brown bags at the university and distinguished lecture series, and I've seen many of your faces at some of those, so you know how those work, very popular. But this is only our second public outreach event. Our first one was on global health, and we have some of our speakers from that panel here. It was held at Cafe Mocha, and this is our second one on climate change. And I'll introduce the panelists in a moment. But I want to just thank you all for coming and emphasize that the way we're trying to outreach here is to have each of the panelists speak for approximately 15 minutes, no more. I've laid down the law, no more. And they come from different disciplines, so there might be some interesting differences among them, which is fine. But the most important part is the exchange with you. So after they finish speaking, we'll open it up for questions and discussion. So if people have points they want to make, as long as you don't make another 15-minute speech, we can have a kind of a dynamic exchange and discuss these problems because they're...
Do you have a microphone or something?
No, we don't have a microphone, but I think once those windows are closed, it'll be better. At least I hope so. We'll try to speak loudly. There are more seats here. If you order from the menu, the waitresses will be coming around, and if you order from the menu, you'll get a little number, and they will bill you directly for your drink and your food, whatever you want to order. And they'll circulate, I think, while the speakers are going. That would be fine. So order from the menu. If you don't have menus, ask the wait people for menus, and we'll move ahead. So these panelists are all very distinguished, and they have agreed on an order. So I'm going to follow what they suggest. The first speaker is Dr. Bryson Brown, who's right here. And he has recently collaborated. He's a professor of philosophy at the University of Lethbridge, and he's recently collaborated with two researchers at opposite ends of the country for his latest grant to pursue his research program on preservationism, applications and extensions. I won't go through his bio, but he writes on logic, philosophy of science, and several other topics. Some of his most recent works include a book on the history and principles of evolutionary thought and a co-edited volume on philosophy of ecology. So that's part of his bio. I don't want to take the time to go through each bio in detail because that takes the time away from what they want to say, and I'm eager to hear what they have to say. The second panelist, agreed by popular consent, is Dr. James Byrne, who is professor in the Department of Geography, also at the University of Lethbridge, and his primary research program includes high-resolution modeling of environmental change, specifically variability and change in the areas of alpine hydrology, mitigation and adaptation to global environmental change. He's been at the University of Lethbridge, I always do this, University of Lethbridge for quite a long time. He was director of the Water Resources Institute, which many of you know about, for a period of time, and 2 years as chair of the Department of Geography. Again, I can't go through all of their lengthy bios. Dr. Gwendolyn comes from the University of Calgary, where she is an assistant professor in the Faculty of Communication and Culture. And her research focuses on the various ways in which lay publics engage with science, particularly in informal, non-traditional settings. She's been at the university, she was in the Department of Geography in 2010 and then transferred into the Faculty of Communication and Culture, where she teaches science, technology, and society. She's part of, I don't see it here, she's part of the Alberta Climate Exchange Dialogue?
Alberta Climate Dialogues.
Alberta Climate Dialogue, sorry. I can't skim through here and find it quickly, which is a community and university research alliance network on Alberta and climate. So I hope you will hear more about that. So we'll turn to Bryson to start, and then we'll move right along. Order food. The people will be coming through. And I'm going to keep the time.
Well, thanks very much for the introduction, and I'll try to stand and look in both directions and keep up with where I'm at as we go along. I'm going to skip through this fairly quickly because I've got a fair number of slides, and the main points I want to make concern what we know in general fundamental terms about global warming and our contribution to it, and then say a little bit about some recent work that suggests that the problem we're facing is already very, very serious and that we're going to have to work quite hard if we want to avoid disastrous consequences. So that's, of course, where I get my title, sort of a gloss on Louis the 14th, Louis the 15th, who said, "Après moi le déluge," understand? Because he could see that things were coming apart in France at the time. And so here's a question for us tonight. Après nous le déluge? Is the flood coming after we're gone? Some basic points. Greenhouse gases warm the Earth's climate by preventing heat from being radiated directly back to space. So the surface of the Earth is quite a bit warmer than it would be without the greenhouse gases in the atmosphere. CO2 is the principal or the main non-condensing greenhouse gas in our atmosphere. Water is also important, but water condenses when temperature drops. CO2 doesn't. Its freezing point's a little too low for that. So the levels of water vapor actually depend on temperature, and that means that if something warms the planet up in general, you evaporate more water into the atmosphere, and that actually amplifies the amount of warming that you get. Conversely, if something cools the climate, generally you lose some water vapor overall, and that tends to amplify the cooling. So, let's see. Here's a chart of a famous set of observations at Mauna Loa in Hawaii, showing CO2 concentrations from, well, here 1960 on to, I think, not quite 2010. The ups and downs are actually seasonal. During the northern summer, CO2 levels go down because so many plants are active in the northern hemisphere, which has a lot of land mass, and they absorb CO2, and CO2 levels drop a little bit, and then in the winter they go back up again. So it's back and forth, but as you see overall it's going up, and we expect to hit 400 probably next year from a starting point of about 280 pre-industrial. Where does the CO2 come from? Well, CO2 participates in a natural cycle from the atmosphere to plants and oceans, and back again as plants die and decay and oceans release CO2 back into the atmosphere. Some of it ends up buried in plant matter, and that eventually could form fossil fuel, or as carbon in soils, in permafrost, for instance. Burning fossil fuels adds CO2 to the atmosphere, obviously enough, and the new CO2, you can tell it's different from the other CO2 because it's C12 enhanced, a particular kind of carbon, and it's C14 depleted. Again, another kind of carbon that decays, and so in fossil fuels there just isn't any. As CO2 levels have increased, C12 over C13, that ratio has increased, which tells us that this is fuel, that this is CO2 that comes from living matter, ultimately, or matter that once was living. That's how it gets CO2 and C12 enhanced. And O2 is actually decreased as well, so it suggests it's a combustion process that's responsible for these changes. And so far, the rate of increase has shown that the atmosphere is accumulating about half of what we're emitting, roughly. The oceans are absorbing most of the rest, though that may not continue. The Earth will warm then. That's what's going to happen. Doubled CO2 will raise temperatures by itself by about 1 degree C. That's considered a pretty straightforward calculation in atmospheric physics. Feedbacks amplify this. You get increased water vapor, as I've already said. That will roughly double the warming based on CO2 alone. You get reduced albedo because there's less snow and ice, especially in the summer months up in the north. And so open water and land absorbs more heat. And warmer soils and waters over longer periods of time will actually release carbon or methane that have been stored. So there's a possibility you could even lose control of this. It might not just be us contributing at a certain point. Short-term sensitivity, that is to say, over a reasonably brief period of time, how much temperature rise do you get from doubling CO2? Between 2 and 4.5 degrees Celsius is the general estimate, and that's sourced from a lot of different calculations. Not just models, but looking back into the history of geology and proxies that measure temperatures during the ice ages and temperature changes, and we understand some of what causes those temperature changes. And so we have a number of different sources for that calculation. We also can expect the oceans to rise 1 to 2 meters by the end of this century. And that's warming waters and melting land ice. And then over coming centuries, we can see them rise by quite a bit more. You've got up to 7.2 meters worth in Greenland's ice cap. You've got another 5 to 6 in the West Antarctic ice cap, and a total of 61 if you actually eventually melt all of Antarctica. That presumably takes a long time, but in the meantime, you've got continually rising sea levels for centuries if we end up with substantially higher temperatures than we have now. So we can look at what we're doing right now, where we're going. CO2 levels are now increasing at about 3% per annum. That's ahead of pretty well all of the scenarios that people have projected. We're going to double pre-industrial levels of 280 parts per million by about mid-century if we follow high emission scenarios. And right now, we're actually ahead of the high emission scenarios. Significant emission cuts that would have to start soon and continue up to 2050 are required to avoid even higher levels than 560 parts per million. And stabilization at 450 parts per million looks almost impossible already. It's a very, very tall order to reduce our emissions enough to avoid going over 450. Given other greenhouse gases and other sort of feedback effects, 450 parts per million has been widely sort of discussed as a kind of cutoff level above which you would expect temperature increases beyond 2 degrees C, which is considered to be a kind of level that you pick, dangerous, potentially catastrophic, really. And as I said, we'll reach 400 probably sometime next year. So here's fossil fuel plus cement emissions, because making cement uses a lot of energy. And you can sort of see how bumpy it is when you look on the smaller scale of the last 20 years or so. But you can also see, a slight actual downtick in the year when the recession hit, 08-09. Then 09-10 was a big rise that more or less made up for that. And then a little over 3%, 3% in 2010-11 and 2.6% in the last year in terms of the rate of emissions that we're seeing. Here are some related charts. This is a chart showing some long-term projections of emissions from fossil fuel burning. So this is a high emissions projection. This is a little bit lower, but still winding up at the same place in terms of emission levels. This is a long, slow decrease. This is an earlier, slightly sharper decrease that then levels out. These are projected CO2 concentrations over time, the black bar being up to now, and then projecting in different directions. And this is a sort of amplified section of this graph showing you that all of these projections start off very close together, and our actual emissions are well above all of the projections at this point. Let's see, yeah. So what are our options if we want to do something about this? What can we do? Well, we have to focus on total emissions. That is to say, we have to focus not on how much we're emitting today or how much we emit tomorrow or how much we emit in 10 years. What counts is how it all adds up. Because the carbon that we emit now into the atmosphere, broadly speaking, stays in the atmosphere for thousands of years. So what we emit isn't going to go away, it's just going to add up. And filling the bathtub up fast, filling the bathtub up slowly, either way, if we fill the bathtub up past the point where it's dangerous, then we're going to be in trouble. We can compare alternative paths for emissions by integrating the curve of emissions, just adding up the area under the curve of emissions over time. Okay, thanks. Lower emission rates in general aren't enough. We saw some of those charts where the rates got fairly low, but then they continue at a fairly substantial level. And if we really want to avoid going past 2 degrees Celsius and warming, we have to approach zero net emissions in the latter half of this century. And we can look at different emissions curves and sort of check out what we have to do in order to get there, in order to prevent getting into the territory where we expect 2 degrees or more than 2 degrees of warming. sometimes substantially more. We can consider different turning points, points at which emissions peak and start to fall, and then we can consider different rates at which we actually reduce the emissions. 3% per annum, that can happen, say, in a worldwide recession. 5%, it's a little bit more to ask. Now, it needn't be a recession that's associated with these things, but that's just to give you the scale of the economic impact. We have to make changes that are going to be very challenging for the economy in order to change at 5% or 10% per annum. That would be a huge challenge to change your energy systems over that quickly. So here's one path. Here's a high emissions path where we end up at 4 to 6.1 degrees Celsius according to the estimates that you get from integrating this curve of emissions and saying how much CO2 have we got in the atmosphere then, and has it stabilized relative to, say, the levels we had here or something like that, and you're saying 4 to 6 degrees Celsius. Here's a path where we get to 1.3 to 1.9 degrees Celsius temperature rise based on the estimates, and that's always some uncertainty, so you can go a little bit warmer there, or it might not warm quite that much, but broadly that's a good calculation of the range you could expect on this emissions path. And this emission path says we get to 2020, and then we have to start cutting quite drastically. You see, we're going up about 3% a year here. This slope is rather steeper than that, so you're probably looking at about 5% per year from roughly 2020 to 2070, and you're hitting about 0 at 2070 to get there. So this is the judgment of Kevin Anderson at the Tyndall Centre for Climate Change Research in Manchester. He says it's probably impossible now to prevent warming of 2 degrees C or more. He thinks we need to peak in 2016 and reduce by 4% per annum from there on in, right down to essentially 0 to do it. So far we've had about 0.8 degrees, I think, from pre-industrial. Celsius 0.8. So 2 would be, 1.5 times what we've already warmed. We're seeing some fairly interesting effects already. And I use interesting rather than a grimmer word just because. And so 2 degrees C is not a, not a sort of trivial thing, although 2 degrees C warmer in the weather is not a big deal. 2 degrees of fever feels pretty lousy. And that's essentially what would be happening to the ecosystem worldwide if we have 2 degrees C warming. Besides which, in some places, 2 degrees C warming average would be higher further north and higher in certain overland and higher in other areas. Anderson thinks it's very challenging to keep warming below 4 degrees Celsius. If you want to keep it below a 40% probability on our current information, you need very serious measures to be taken within the next 5 to 10 years. And the longer you put it off, the harder you have to try, the faster you have to run to change direction enough. But he says 4 degrees C is really unacceptable. If that's where we're going, we're not going to be happy. Warming, of course, is higher over land and away from the tropics. Agriculture is going to face challenges as a result of this. You lose productivity at higher temperatures. You lose regular patterns of precipitation that agriculture in particular areas relies on. You get deeper and increasingly common droughts. We get significant ocean acidification, which is a threat to sea life. And you get, again, 1 to 2 meters of sea level rise by 2100, and that would continue for centuries. So we really don't want to go to 4 degrees C, but right now it looks like hard work to avoid it, at least according to Anderson. So what can we do about this? Okay, I'm pretty well done. I'll just say this. This is an accounting of what we can burn out of our fuel reserves. And if you look at stated reserves today, given the levels of CO2 that we're prepared to reach and think that we could stay under 2 degrees, we need to burn at most 20% of total stated reserves now. Thanks.
Thank you. The next speaker is Jim Byrne from Geography at the University of Lethbridge.
Oh, Blaine, we got to move you out of that corner. You're being blocked by our camera guy, hey? Want to slide your chair around a little bit, perhaps? We'll Try to get to you. Okay, thank you. It's wonderful to be here. Quick audience participation. I want to find out who you are. Okay? If you were, when you were a little duffer or duffette, assuming you grew up, how many of you grew up in a cold country? Cold winter? Hold your hands up high.
Cool.
Yeah, okay, where there's a cold winter, keep your hands up if you grew up, okay? How many of you had your mom or dad tell you, when you were just little, don't put your tongue on cold metal in winter? Keep your hands up high, keep your hands up high. How many of you put your tongue on cold metal in winter? Okay, we got a very empirical audience here, and that's interesting, very scientific audience. I did that with social scientists. And, oh, thank you, that's good enough. Yeah, I did that with social scientists, and I found only about 20% of them. They actually listen to mom and dad. The scientists are like 80%, their tongues all get stuck to cold metal in winter. Okay, so where do we want to go? These are my objectives. These are my objectives. Who causes climate change? Very quickly, I'm going to set it up. Us versus them. Developing world versus developed world. Okay, then what are the impacts, regional and global, and how do we fix it? Okay. Would you be mad at me if I said I don't care about the Earth?
Yeah.
This isn't about the Earth, actually. You know what? The Earth will go on and develop wonderful ecosystems way after we're gone. This is all about us. Climate change is going to hurt people. It's sad polar bears will disappear. But you know what? Most species have disappeared. Okay? The Earth will do just fine without us. This is about saving people. Okay? So, historical per capita greenhouse gas emissions. This is setting up the developed world versus developing world. India, China, Europe, North America, Alberta. Is Alberta developing or developed world? I think I'm trying to remember. Okay, Alberta. This is our recent emissions. India about 1.4 tons per year. China 6, Europe 10, 25. Alberta 70 tons. If you look at it in historical perspective, since 1960, a Chinese citizen approximately 25 tons. China 100, Europe 400, North Americans 800, Albertans 1,500 tons of emissions since 1960. I hope I'm making you feel guilty. Okay? Now, that tells us the developed world has to lead in emissions. Our historical emissions are huge, and we're causing most of the climate change right now. Okay? Now, I just want to let you know that 1,500, that's not the average Joe Albertan or Jane Albertan. We're about like a normal North American, all of us in the room. It's the energy industry. It's the fossil fuel energy industry that's emitting all of those, and getting rich doing it. The most profound danger to world peace in the coming years will stem from the legitimate demands of the world's dispossessed. The majority live in a marginal existence in equatorial climates. Global warming, originating with the wealthy few, will affect their fragile ecologies most. Their situation will be desperate and manifestly unjust. I wonder who said that. About 100 Nobel laureates said that in 2001 in their message to the world. The situation is worse now. It's even more compelling, and we're seeing those tremendous hits on developing world, ecologies, on human ecologies in the developing world. We're seeing unprecedented flooding in Pakistan. This gentleman has lost his home because of our emissions. These folks have lost their place to live and a place to raise their food because of our emissions. These folks have lost the place. Flooding, drought, we're seeing it all over the developing world. But not just in the developing world. Your insurance rates went up by 15% to pay for $700 million in losses. This is the Insurance Bureau of Canada talking, and these folks are pretty conservative. $700 million they had to cover in Slave Lake. You don't have fires in Slave Lake in early May. In Alberta, Slave Lake should still be soaking wet or perhaps still covered in snow in early May in Alberta. You don't have grass fires in Nanton on January 4th. Nanton should have between 15 and 50 centimeters of snowpack on January 4th. Instead, it's so tinder dry that we get these massive fires. And why do I know that? Why do I think this is going to impact you directly if it hasn't already? That's my brother's house.
Wow.
The Cardston hailstorm. nearly fist-sized hails this last summer pounded so many people into oblivion. One poor guy tried to run out to his car to move it into the garage and he got knocked unconscious. That was part of the least of the damages. I'm sure he recovered. But again, about I think 200 million in losses. Insurance Bureau of Canada. We're all going to pay for that, right? Looked like that. Just happened to be that those were all my in-laws, and I happened to love them, so I wasn't mad that it was or wasn't happy that it was my in-laws, right? We're going to all see these kind of impacts. We put out a video which has gone around the world now. I don't know how many people have seen it. I hope you've seen it. It's called Climate Change. Do the math. Google it. It's got a lot more of this in it, and it's got a lot more of the numbers and things that are going to present you. It's only 12 minutes of your time. It's been seen in 120 countries. I don't have any idea how many people have seen it anymore. I've just lost track of it. All over the U.S., Joplin, Missouri got wiped out. Massive tornado outbreaks. Massive drought, right, in North America. Massive drought in Africa. Massive drought in India. Massive drought in Australia. We can't keep this up. We're going to have to start paying for it. This is U.S. temperature records, high temperature records. We're getting 4 to 10 high temperature records for every one low temperature record. The statistics on that are just so far out. It's, we have to. Australia invented, they added colors to their temperature scheme for plotting what happens to Australia in summer. They never had temperatures of 54 degrees Celsius. How fast would you tan at 54 degrees Celsius? Right? You can darn near cook your burger at 54 degrees Celsius, right? Okay, the world is heating up so much. We've really got to do something about it. Our oceans are dying. Now, don't worry. Susan has a complimentary Prozac for everybody before we leave. Okay, so it's really not that bad. Plus, I'm going to get to some good news in just a minute, okay? But our oceans, well, I saw some faces that just looked like, holy mackerel, I'm not even going to finish this drink, or I'm going to have another one right away. Our oceans are dying. We're acidifying our oceans. Bryson mentioned how much of the CO2 is sequestering in the ocean. Makes carbonic acid. It causes the whole ocean ecosystem is based on calcium. It's basic. So we're hurting our ocean ecosystems. Arctic sea ice shrunk to an all-time low. Now the ice scientists figured 2030, 2040 we might have an open Arctic Ocean. Now we think 2013, 2014, 2015. Right, we're going to have an open Arctic Ocean. That caused Sandy to turn and kick North America, to kick New York and New Jersey's butt. All that cold water coming out of the north and all that cold air, that blocked. And Sandy, instead of taking off towards Europe, Sandy went bump into that and turned over into North America. Sandy is the biggest, most powerful storm we've ever seen. It was only Category 1, 1 to 5, right, for hurricanes, but a Category 1. And, but it was the massive diameter, the greatest energy we've seen in any storm. The U.S., who is that? It's NASA. NASA had just finished up a shoreline protection program in August 2012 for their facility in New Jersey. Along came Sandy and wiped it all out and destroyed it. We need a whole new level of adaptation. Right? This is post-Sandy on this side. Completely all of the protective works were lost. Playgrounds couldn't be used for a number of days. People were displaced. Streets were flooded. Homes were flooded. And then you go over to Beijing Air Pollution. It's not just Beijing, though. I'm going to come back to this in a minute with health. Beijing, Los Angeles, Calgary. See that nice dark pollution? The mixing layers right there, and there's Calgary. There's the Calgary Tower. I don't know why they should change the name from tower to something else. They don't quite understand the name tower anymore, what it means. But anyway, that's the Calgary Tower. About 5 minutes, okay? So where are we going to go? We're going to get off fossil fuels. Stern report says it's going to cost $1 trillion a year, more or less. Nobody in this room has that kind of money except my friend Mark Sandilands, okay? So if Mark would help us out, that would be great. Okay? $1 trillion, that's huge, that's massive. That's about 1% of the global economy. But here's what we're spending on fossil fuels. A number of agencies, I'll give you the references, $500 to $700 billion a year in subsidies to the fossil fuel industry. Okay? $1.2 trillion a year directly attributable to climate change. $2 trillion a year we spend on petroleum. $750 billion we spend every year on coal. Right? And then healthcare costs, this is the tough one. National Academy of Sciences in the States says healthcare costs due to fossil fuel pollution is about $120 billion a year. In the US, 4.4% of the population. I rounded it up to $1 trillion. That's the toughest one to try to figure out exactly what to do. So getting off fossil fuels will save us $4.5 trillion a year. This stuff about it's going to cost us more and we can't afford it, you know what that is? You know the American Sign Language, this one? You know what this is? This sign? This is the horns of the bull. Right? We can fix this. It's only because the fossil fuel industry doesn't want us to quit spending money. You know, this is the number of impact events, major natural catastrophes due to meteorological events, weather events, storm events, due to climate change. From 1980 to 2005, they've gone up from 50 to 200 a year on average. Who said that? Just Munich Re, one of the biggest reinsurance companies in the world. You know, so it's so workable. Now I'm going to leave you with this. You can fix it. You can fix it really easily. This is a great published paper from the States, good refereed work. This is a daily electrical demand that we all have in our society. And this is where we generate electricity all the time. We generate way up here just so we can meet these peak demands. We waste most of this electricity in here and over there. So you're all going to run out and buy an electric car tonight. And we're going to fix this. Because electric cars hold a key to the future. Your electric car, hey, come on, show up there. Your electric car can be plugged in all night long. Use this wasted electricity. This is refereed work, okay? This isn't my dreaming. So your electric car can use that waste electricity. Your electric car can be plugged in the evening and use that waste electricity. During the day, you only drive your car on average about an hour a day, if that. During the day, your car's plugged in at work or at home, and you know what? When we get to that good point, the electric system says, hey car, we've got whatever, 80 million electric vehicles in North America. We want some electrons back. And they'll pay you to give those back, to take that top off. So we'll get to a point where instead we'll have a curve that looks like this. We'll be using this electricity. We'll be reducing that peak. We'll be emitting much less coal-fired electricity overall. We'll be eliminating the greenhouse gas emissions for 86% of light cars and trucks. That's right out of the referee paper. Okay? We can do this very efficiently, and the health benefits of that pollution reduction are massive. Massive. The Chinese are getting into this. The Chinese are every car maker over there is making electric cars. I'll leave you with this. Mark Jacobson from Stanford University has done the works. Mark, brilliant man. He's got a whole research team. I know Mark very well. He's spoken in sessions that I've chaired. We can go to renewables. We can get off fossil fuels. Look this up, and I'll send this. I'll make the presentation available. Can we put it on a website or something? Is that what we're going to do? Yeah, it'll be available on the website. You can read this. This is great, written in good communication language in Scientific American. Here's how we're going to do it, and we can fix it, and we can, make a better world for ourselves. The Alberta Canada Economic Plan. Really, really bad bet. A really, really bad bet, okay? This is our economy right now. Alberta, this is right off the Alberta government website. Look at the diversification. Yeah, energy 27%, agriculture 1.8%, everything else is non-primary industry. If energy collapses, so does our economy. And I can tell you, I know the people down there. I meet with them. I almost know Stephen Chu, the former Secretary of Energy. I've emailed with him. Obama's people are going to change this. The U.S. is getting off fossil fuels by 2030. Our oil sands are not a good bet. We should go renewables with the money we're making out of oil sands and out of energy as fast as we can. Diversify our economy, and we'll do a lot better. So let's do that. We've got climate and weather on steroids. This is my last slide. We've got climate and weather on steroids now. And it's just going to get a lot worse. The damages are going to get more. The losses, life losses. We can cut greenhouse gas emissions. We can go electric. We can save on health. We can do power grid conversions. This is not hard to do. So, and Alberta should be going green. And right here in southern Alberta, we'll be the new Fort McMurray. We've got all the sun and all the wind, and we can actually, power the economy. So all that about fossil fuels is just not true. So thanks for listening, and how am I doing?
Thank you. Transition now to Dr. Gwendolyn Blue from the University of Calgary.
Right there, right?
Hi everyone. I just want to say thank you to Susan and the Prentice Institute for having me come. I'm the only one who's not from Lethbridge. I made my way from Calgary. Jim is a really hard act to follow, so I'm hoping that I don't put you to sleep, but I will stay on time. I want to start with a claim that's actually going to be a bit different than what we've heard, although following up definitely in agreement with everything that we have talked about. But I'm afraid that Jim left us on a happy note, and I'm going to bring us down again. Sorry. But it depends on whether your glass is half empty or half full. So I actually think that this is an invitation, and an invitation of possibility, as opposed to something negative. But it's going to sound negative just at the start. So I actually think that with climate change, we need to do a lot more than technological solutions. I think we need to do a lot more really, really deep thinking. We need to question what it is that we, and by we I mean, how about those of us in this Western industrialized world that have inherited a particular tradition, a particular way of thinking? We need to rethink our understanding of nature. That's the first one. We need to question it, and then I think we really need to challenge what it is that we mean by the natural world, especially this thing called climate. We also need to rethink and question what we mean by humanity and humanity's place in nature. And the third one, we need to spend some serious time thinking about what we can and do know about the natural world and about the social world. Now that's a big project, and I'm not going to go through even a fraction of what I just said, but I'm going to talk about knowledge here. But first, before I do that, I'll tell you a little bit about myself and how I kind of came to that statement, all right? And I have no easy solution, so that's more of a provocation than anything else. I moved from communication to the Department of Geography when someone told me that we're all at heart geographers, and so I actually took that to heart and made my way to the geography department and didn't get lost, so they let me in. I have a terrible sense of direction, so the joke is, how am I a geographer? But then I say I'm a postmodern geographer, so I don't have to worry about maps. I'm involved right now in a social sciences and humanities research project that was a former CURA, which is a Community University Research Alliance. We no longer have that particular program, but the program itself is really quite interesting. It began in 1998. It was actually based on deliberative processes that try to bring people into conversation about scientific and technological issues. It's processes similar in Europe that have science shops, consensus conferences in Denmark, and the intent of the CURA was to enhance community and university relationships in order to bridge that gap between what we'll call lay understandings, I hate that term, I just don't have a better one, and so-called expert communities. And the idea is that we are going to bring a diverse set of interests and values together in order to solve some of the major problems of our time. And Alberta Climate Dialogue is a 5-year project, and we're right smack in the middle of it, that's exploring how it is that direct participation can change or alter the conversation around climate change in Alberta. This is a group that consists of university, government, civil society, and industry partners, and we have practitioners in Canada, US, Europe, and Australia. And the idea is that we're going to bring the principles of deliberative democracy to bear on climate change. There has already been a very large-scale event in Edmonton that has taken place looking at Edmonton's energy futures, and there are 2 more events that are going to take place. One of them will be in southern Alberta around climate change and water, and if anyone's interested, I can give you some more information on that. We've already heard a lot of really good information about the problems with climate change, so I'm not going to go through any of that, but what I want to talk about is what it is that we can do when we add democracy to the mix. There is, on one hand, a desperate need for informed debate around climate change. We have a lot of misinformation that is circulating through our media, some of it very, very strategic. But also, climate change is an interesting phenomenon. It's what has been called a wicked problem. Not wicked because it's morally bad, but wicked because it's so intractable that it's actually challenging us on many different levels. And it's also temporally and spatially removed from everyday life, particularly when we're looking at those global processes of climate change. Although in the Western world we're seeing extreme weather, but we never actually experience climate change directly. We experience the weather. In fact, we never experience climate directly because climate is an abstraction. It is a statistical accumulation of different weather patterns. It's also something that's caused by an invisible agent. We cannot see greenhouse gases, so we can't pinpoint what is happening. And so we do have to put a lot of our trust in scientific organizations that for the most part are removed from the everyday lives of people. And there's an incredible amount of complexity, spatial complexity, temporal complexity, scientific complexity, as well as multi-generational complexity. So we have a problem that is not only something that we need to deal with across the generations that are alive, but something that we are leaving for our children and their children. So it really is something that's taxing our understanding of politics and our understanding of ethics. And as a result of this complexity, we need to accommodate multiple views. So it's not enough, in this case, to have an expert-based solution in order to find the ways that we're going to maybe get out of this problem, maybe, if you're an optimist, maybe dealing with the issues that we've put in place. And I actually think that we are going to be needing to focus a lot of our efforts on adaptation. Mitigation is important, definitely. I'm not saying it's not, but I think that we also need to be aware that we're going to need to adapt to the changes that are coming along. But I also want to say that climate and climate change is as much cultural as it is biophysical. And the idea of climate has captured our human imagination for quite some time, coming right back to the ancient Greeks, where we actually got the term climate from, meaning inclination. And we've had diverse and various meanings attached to this phenomenon of climate and increasingly to the phenomenon of climate change. And that's something that we also need to think about, that the cultural dimensions of climate change often get neglected as we focus our attention on the scientific aspects of climate change. And I want to say there's no neutral way of discussing climate change at all. We are all embedded in a political discussion when we are talking about climate change because of its very, the scale. Climate change defies elegant and consensual solutions. It's not going to be something that we can solve in the way that we solved the ozone problem. I think that climate change is going to force us to perhaps come up with divergent responses, and in many cases it's going to force us to come to some pretty deeply seated disagreements. Now, one of the challenges that I have, because my academic training is in two different fields. One is in a field called cultural studies, and I'm very interested in this phenomenon called culture. How is it that culture emerges? What do we do with it? I'm also interested in a field called science studies, and that is how does science operate as a mode of cultural authority. And this is the problem that we have within public communication about science and technology. That for a very long time, throughout the 20th century, we used a process, and we still do in many cases, called the deficit model of public engagement. And the idea was that the public was deficit of knowledge. And so the intent of science communication was to fill the minds of the public, much like you would fill an empty glass full of water. The problem with that model was that it was linear. It was an idea that knowledge was transmitted from scientific institutions that were never actually part of the process of deliberation. And that the assumption that publics did not have knowledge to bring back to the discussion. And the framing of the debate remained primarily scientific. Now, for a lot of reasons, the deficit model has been proven to be ineffective. That you cannot change someone's mind by giving them more information. because we filter our understanding of the world through our worldviews, through our underlying assumptions. We basically hear what we want to hear, and even though we may attempt to get beyond that, it is really quite difficult to do so. So, I think it's really interesting. Is anyone here from the UK? Anyone know? Okay, we got one person. Okay, we'll know what I'm talking about. I think the UK government was, I mean, we rarely see this level of reflexivity at the level of government institutions, but they had definitely implemented a deficit model of public engagement, and they switched to what I'll call a co-productionist, or more of an engaged two-way model. And this was actually at the level of official policy. So they went from this one-way linear kind of transmission, what was called the public understanding of science, to public engagement with science and technology. And there's been many claims that we have a new mood for dialogue. A new mood for dialogue between publics, and I'm using the term science, but what I really mean are those expert institutions that are in charge of producing the knowledge and also giving advice for our policies. So we're in an era right now of dialogue, of engagement, and I think more deeply of what's called a co-productionist model of engagement. And this is interesting, is that we've gone from thinking about publics, those lay publics, as being void of knowledge, simply needing to be filled, to actually having something to say. We've also come to a realization that science, and here I mean all research, I should actually call that research. The research is important, don't get me wrong, but research is also provisional, it's contextual, and it needs to be part of the public debate. Not, and here I think this is where people get confused. We don't bring publics into conversation about science and technology to talk about science and technology. We bring publics into conversations that are public issues, and that science and technology informs that. But what publics can do is get to those normative ideas, those value assumptions that we all bring to bear, and that members of our expert communities also have. And that's what I'm arguing that we need to put on the table, is our normative assumptions about nature, about society, about capitalism, about the kinds of capitalism that we've inherited on a global level, about our understandings of who is going to speak for the climate, who are we going to put in charge, and who is going to reap the profits, and who is going to suffer from any policies that we put in place. And I am, I think at heart, an optimist, and I do believe that there is a power when we come together in a meeting of minds, that we can get to a place where we can have not one solution, but many solutions. There are challenges, however, and I think one of those challenges is the ways in which we have made the climate discourse into a corporatist discourse. And by that I mean is that large corporations are spending a lot of money to get to sway us away from understanding what the real issues are. And we need to be attentive to those large power structures as we also figure out our own cultural conceptions about climate change, and ultimately about our relations with one another and with all of the creatures on Earth. And I'll leave it there. Thank you.